Hello. So in MATLAB lecture, we'd be talking mainly about MATLAB arrays, the different types of arrays, how we declare them, and then we'd be diving towards some of the examples on arrays. So first of all, what is an array? Well, the example that's given on this slide is that suppose the concentration of a tracer can take up different values at different locations. So if you want to store those concentrations at different locations, then the variable that stores these different values is called an array. So generally we store a single value, a scalar, in a variable, but if you have more than one value for a single variable, then that variable is generally called an array. So there are different ways that you can declare an array. So first let's talk about single dimensional arrays, and then in the next slide would be diving towards 2D and then 3D arrays. So generally you declare a MATLAB array, a single dimensional array, by enclosing the values inside a square bracket and by separating them either with the space or a comma. So that's the first way that you can declare an array. Let's see this in action. So suppose that I want to store the concentration of a tracer at different locations. So I store it in a array C, and I store the values by enclosing them inside a square bracket. So let's put some random values. Let's say 3, space 4, space 5, 7, 8. So as I discussed in the previous lecture, if you terminate a MATLAB statement with a semicolon, then the result is not printed to the command window. But if you do not end it with a semicolon, then it is printed to the command window. So suppose I want to print the result to the command window, then I do not terminate this statement with a semicolon and I hit enter. So that's how you declare an array. Now this array C has got values 3, 4, 5, 7, and 8. So it's a single variable and it has got multiple values. And that's how a single dimensional array looks like. There are other ways of declaring a single dimensional array. The second most popular way is by declaring it by specifying the starting value, the step size, and then the end value. So what do I mean by that? Let's declare another array C2, and suppose that this array, again I'll enclose the values inside square brackets. Suppose this array starts from 1, it takes a step size of 2, and it terminates at a value, let's say 20. So this is the starting value of the array, this is the step size, and it's the end value of this array. If I hit enter, as you can see that the array starts from 1 and there's a step size of 2. So after 1, the step that is taken is 2, and the second value is 3, then 5, 7, 9, and so on. So that's another way of declaring an array. So it is convenient in a way that if there are more than there are a lot of values and you cannot declare them by typing them manually, so you can also type them in this way. So that's the second way you can declare an array. Now this array C2 is its values are printed horizontally. So basically this is the horizontal values that you see here. Basically it's called a row, so it's a row array, you can say that. But if you want to declare an array in vertical direction or in a column, you can also do that. So suppose I want to declare another array, let's say C3 equals to, and now I want the values to be stored inside this array in a horizontal, in a vertical direction. So I can do that by putting the values, and here instead of giving it a space, I'll terminate this value with a semicolon. So if I terminate the first value with a semicolon, and then I put the second value, let's say 2, semicolon 3, semicolon 4, and so on, and now I hit enter, as you can see that the values are now stored in a vertical direction. Generally, this is called a column, and this is called a row. So that's how you declare an array column wise. In the horizontal or in the row direction, there are two ways you can specify the values, differentiate two values from each other. So, for example, the first array that I declared here by giving a space in between, you can also separate these values from one another by putting a comma in them. So what do I mean by that? Well, let's declare another array or the same array, but here we'd separate the values by giving a comma in between them instead of giving a space. So 3, 4, 5, 6, 7, 8. If I hit enter, as you can see that it has got the same result as I declared it in the first array over here at the top. So that these are the two ways that you can differentiate the values from one another when declaring arrays horizontally. So those were some of the examples of a single dimensional array. Now there are other types of arrays also. So there are 2D and 3D arrays and even higher dimensional arrays. Let's discuss 2D and 3D arrays now. So in a 2D array, there are values both in the horizontal direction, that's the row, and also in the vertical direction, or as I said earlier, in the column direction. So let's declare a 2D array, and it will be clear even more when I declare it right here. So let's clear the MATLAB environment by typing the CLC. I discussed this in the previous lecture also. So let's declare a 2D array C equals, again you'll enclose the values inside square brackets, and here you specify the rows as earlier. So let's say I enter 1 space 2 space 3, so it is the first row. Now when I go to the second row, I'll terminate this first row with a semicolon. So I terminate it here with a semicolon. Now the values that I'm entering here would go to the second row. So let's give some values, 4, 5, 6. Again, I want to terminate this row and move to the next row, that's the third row. So I'll declare it with a semicolon, and then the next row, 7, 8, 9. If I hit enter, as you can see that the first row, that's 1, 2, 3, comes over here. The second row, 4, 5, 6 is here, and the third row is here. So there are 3 rows and also 3 columns. So it's the first column, 1, 4, 7. The second column contains values 2, 5, 8, and the third column is 3, 6, 9. So this is an example of a two-dimensional arrays. The 2D specify the rows and the columns. So the first dimension is the row dimension, and the second dimension is the column dimension. So that's how you declare 2D arrays inside MATLAB. You can have different shapes for this 2D array. So here we have 3 rows, 1, 2, 3, and 3 columns, 3, 1, 2, 3. You also can have different values or like different numbers for these dimensions. So for example, I want to declare another 2D array. I'll enclose it inside square brackets, and now in this example I want my 2D array to be to have 2 rows and 2 columns. So here it was having 3 rows and 3 columns. Now I want to have 2 rows and 2 columns. So let's put some random values, 1, 2. So it is the first row. I'll terminate it here with a semicolon, then 3, 4, terminate with another semicolon, 5, 6. If I hit enter, as you can see, so here it has got 3 rows, 1, 2, 3, and 2 columns, 1 and 2. So in this 2D array, it has got 3 rows and 2 columns. So I think I said that I want my array to be 2 by 2, I mean 2 rows and 2 columns, but I mistakenly typed it having 3 rows and 2 columns. So let's declare another array having 2 rows and 2 columns. Again, enclose them inside square brackets. Now let's say 4 5 semicolon 6 7. So this is the first row and this is the second row, and again 4 6 comes in the first column, 5 7 comes in the second column. So if I hit enter, it's the first row, the second row, 4 6 first column, and 5 7 second column. So that's how you declare different types of 2D arrays that's having multiple values along the horizontal axis or the horizontal direction, and in the vertical or the column direction. You can also have 3D arrays. So in order to declare a 3D array, well, it's hard to visualize 3D arrays in visually, but we'd see it with an example. So let's just declare a 3D array. So I typed clear nclc to clear the command window. So first I'll declare a 2D array and then I'll convert it into 3D array. So let's declare a 2D array having 2 rows and 2 columns. So let's say 1 2 colon semicolon 3 4. Again, you can have the row values differentiated with a space in between them, or also by putting a comma in between them. So you can do both. So let's differentiate them here with a comma. So we have a 2D array that's having 2 rows and 2 columns. Now let's convert this 2D array into a 3D array. So the way to convert this 2D array into a 3D array is something like this. So you write k and then you perform the MATLAB indexing. We'll be discussing about MATLAB indexing in the upcoming lectures or in the next slides. But for now, let me do it this way, and then I'd explain it later. So for the first dimension that you specify here stands for the rows, and if you put a colon in here, it means that for all the rows. Now if you for the second dimension here, it specifies the columns. So again, if you put a colon in here, it specifies that for all the columns. And then comes the third dimension, or the since it's a 3D array, so the third dimension comes after specifying the rows and the columns, and then the third dimension. So in the third dimension, the one layer contains values 1 2 3 4. Now the second layer, let's specify it by 2. Let's give it some random values, again enclose them inside square brackets. 2 3 semicolon 4 5. And now if I hit enter, now you can see that it has become now a 3-dimensional array. So in the first dimension, these are the rows, 2 rows, these are the columns, 2 columns, and this one here specifies the first layer of the third dimension. Now this here, all the rows, the columns, and the second or the 2 value here specifies the second layer of the third dimension. I know it sounds confusing right now, but when we discuss more about 3D arrays, or when we would be doing examples on it, the idea will be even more clear next. So let's leave it for now, and we'll be talking about this in the upcoming slides. So let's discuss an example, a simple example of arrays. So suppose that you want to measure the emissions from a power plant, and the area under observation is, let's say, 1 kilometer by 1 kilometer or 1 kilometer square area, and you want to measure the concentration every 250 meters. So if you move 250 meters from the source, you want to take a measure, then another 250 meters, and so on. And this happens both in the horizontal and in the vertical direction, since it's an area. So let's store the measurement points in two different arrays, x and y, that are both single dimensional. Together they'll make a two-dimensional array, but suppose that we want to store both the directions, both the dimensions in two single dimensional arrays. So as I discussed earlier, the ways that we can declare single dimensional arrays. So if I want to declare first the horizontal direction in a array x, so I start from the source, that's 0 meters. Then I take a 250 meter step size, and I want to measure until 1 kilometer or 1000 meters. So it makes the endpoint of the array, and I terminate it with a semicolon so that I do not get the values printed at the screen or the command window. So it's the horizontal direction, same goes for the vertical direction. So I declare it in the similar fashion, starts from 0, takes up to 50 meter step size, and goes up to 1000 meters, again semicolon. So I have stored the location, the horizontal, both the horizontal and the vertical, into different single dimensional arrays. One is called the x and the second one is called the y. If I want to see the values of the x, I'll just write x and hit enter. So these are the values of the x array. Same goes for the y array. So that's how I can store the values. So these different values inside these arrays points out to the locations at which we want to measure the concentration of a CO2 that's emitted from a power plant. So it's a simple example. Now let's move towards some more examples on arrays. So let's now discuss more about some terminologies associated with arrays. So as I said earlier, that an array has rows in columns associated with it. So suppose I declare a two-dimensional array. Let's move towards scripts now. As I discussed in the previous lecture, a script is a MATLAB file that you write code in, and then when you hit the run button, it is executed right away, line by line. So let's create, or I already have an M file stored in my directory. So let's open it. It's an empty file that I created earlier. So on top of the file, let's write the basic commands that clears the variables and then clears the command window of the previous outputs. So let's declare an array. Let's call it A equals to square brackets 1, 2, I'm just putting random numbers here, 3, semicolon, 4, 5, 6, 7, 8, 9, semicolon. So I declare here an array that contains 3 rows and 3 columns. If I remove the semicolon and hit the run button, it is declared and presented at the command window. So as you can see here, 3 rows and 3 columns. So one important MATLAB function that's often used with the arrays is the size function. So if you write size of, or let's write it in here in the M file. If you write size of A, it will return the rows in the columns in the array A. So let's store those two values in two variables. So when you are taking more than 2 outputs from a MATLAB function, you enclose it. You also enclose it in a square brackets, and then the outputs from that functions are stored into those variables. So the first output that comes out of the size function is the rows in a matrix or in an array. The two-dimensional arrays are also called matrix. So when I say a matrix, I'm referring to the two-dimensional array that I declared here. They are both interchangeable, the terms. So the first output that returns from the function size is the rows in the matrix or the two-dimensional array A, and the second output that comes out of the function size is the column in the 2D array or the matrix A. From now on, I'll use the word matrix for the 2D array. So let's terminate this with the semicolon so it's not outputted to the command window. I don't remember if I discussed about the MATLAB comments in the previous lecture, but I'll discuss it here. So anything that you write that starts with the percentage sign, it is used as a comment. So the MATLAB doesn't run it as a code, rather it skips it and ignores anything that comes after the percentage sign. So if I write here anything, it is not executed by the MATLAB, rather it is taken as a comment. Usually the comments are written in order to specify what's happening in the code that it is written for, and other such so like if anyone else wants to read your code, so you leave comments for him or her so that it is readable and understandable. So in the comment here I'll just simply write M is the rows or are the rows, and the variable n are the columns in matrix A. So now this line is ignored by the MATLAB and it is taken as a comment on the code that is written here. So when I run this code, what will happen is that the size function would find out the rows and the columns in the matrix A and will store them into M and N respectively. So let's run it. Now if I write M and press enter, I'll see 3 because there are 3 rows in the matrix A. Same goes for the columns N. So when I hit enter, it returns me the values for the columns in the A, which again is 3. Let's declare another matrix or 2D array that has different values for the rows and the columns. So let's write C equals to 1, 2, 3, 4, 5, 6. Now if I again I want to override the previous M and N. Now for N, you can store it in different variables also if you don't want to override the previous ones. Equals to size of C. So when I run it and print the values for M and N, I see that the matrix C has 3 rows because it is having 3 in the variable M and 2 columns because N contains the value 2. If I print the matrix C, I see that there are 3 rows, 1, 2, 3, and 2 columns, 1, 2. So that's what the size function does for us in the MATLAB. Next is so let's see what happens when we declare a single dimensional array and see the size of it, like what size does it have. So let's discuss another array. Let's randomly call it B equals to, I'll declare it in the step size way that I discussed earlier. So let's just start from 0, takes a step size of 2 and goes up to 20. You can enclose it in square brackets, but the single dimensional arrays can also be when you declare it in this way, in the step size way, you can also ignore the square brackets. But if you write the square brackets, these are like, it won't create any difference. Even the MATLAB tells us that use of brackets is unnecessary. So the MATLAB says that if you declare it in this way and it's a single dimensional array, then the square brackets can be ignored. But let's leave it there. So if I let's run it, and then I'll call the size function. So if I write size b, it returns two values, 1 and 11. Remember that the first one tells us about the rows and the second one tells us about the columns. So if I print the values for b, I can see that it is having a single row and there are 20 columns. So if you count it from here, 1 2 3, sorry, not 20, 11. So there are 11 columns in the 1D array b. So one row and 11 columns. I can also convert this row array with a column array by a command that is called the transpose in the MATLAB. So what is a transpose? Well, a transpose basically it's a concept from the matrices. A transpose is something that interchanges the rows and the columns in a matrix. So for example, let's discuss it first for the 1D array and then I'll discuss it for the 2D arrays also. So I have declared an array B here, and as I print the results for B, you can see that it is having a single row and 11 columns. Let's create another variable array. Let's call it B comp. That's short for complement. And if I write B and I write an apostrophe on it, what will happen is that this row array will be converted into a column array. So let's see what happens. So initially the B is having one row and 11 columns, but the B comp, let's print the result for it. As you can see that the B comp has now a single column, excuse me, so it's having a single column, and now there are 11 rows instead. So first here it was a single row, 11 columns. Now here it's a single column and 11 rows. If now I write the function size on bcomp, what I'll see is this. So it's now having 11 rows and one column. So this apostrophe sign, it stands for complement in MATLAB, and what it does is that it takes the rows and it interchanges them with the columns. Let's see what happens when we call this complement on the 2D array. So we have declared here a 2D array C. Let's write C comp equals C apostrophe and then print the results for it. So C is a 3 by 2 matrix, and C comp on the other hand is a 2 by 3 matrix. So what has happened here is that the rows has been converted into columns. So the first row comes here, 1 2, the second row 3 4 comes here, 3 4, the third 5 6 comes here, 5 6. So that's what this apostrophe sign does. It converts, or it interchanges the rows and the columns in a matrix. Another important functions while discussing arrays is the length space function. which stands for linear space. Basically, it is used in order to uniformly arrange values between two limits. So what do I mean by that? Well, let's see an example. So let's declare an array. Let's call it L is equals to. So I write len space, which stands for linear space. It's basically a MATLAB function that takes on 3 arguments. So let's put the first value to be 1, the second to be, it could be anything. Let's put 5, and then a third variable, let's put 10. So what do these each specify? Well, the first value is the starting point, the second value is the end point of this single dimensional array, and this 10 specifies the number of points between these two variables, including these two. So what the MATLAB would do is that it will create a single dimensional array that starts from 1, terminates at 5, and in total it will contain 10 values that are uniformly spaced. So the difference between two values would be same throughout. So let's check it. Now hit the run button. Let's print the results for L. So the result is presented to us in this shape. The MATLAB is saying that from 1 to the column 1 to 9 the values are these, and then column 10 contains this one. It has become a bit lengthy. Let's reduce the size and then see. So now it will contain 8 values. If I print it now, so you can see that this single dimensional array L contains 8 values that starts from 1, terminates at 5. So here's 1, here's 5, and in total it will contain 8 values. So if you count it, 1, 2, 3, 4, 5, 6, 7, 8. And the difference between any of these two values, so if I take these two values or these two or these two or any two consecutive values, the difference between them would be constant because they are uniformly arranged. So let's verify it. Let's take this the difference between these two values. So if I write 1.5714 minus 1.000, so the difference is 0.5714. Now let's check the difference between these two. So if I take this value, Control C, Control V, subtract this one. So I'm a bit lazy here and I'm just directly copying pasting here. So as you can see that the difference between these two is the same as the difference between the earlier points, which is 0.5714, 0.5714. So that's what the linspace command does, or the function linspace does. The first argument is the starting point, the second argument is the end point, and the third argument specifies the number of points, including these bounding limits. So let's take another example. Let's call it S equals to linspace starts from 0, terminates at 200, and has 5 values or 5 points. If I run it and print the result, you can see that here are 5 points between 0 and 200, and they are uniformly spaced. So 100 minus 50 is 50, 150 minus 100 is 100, and so on. Okay, so earlier I was discussing the different ways that we can declare arrays inside MATLAB. The one that I discussed earlier was having a step size. So just for clarification, you can also have a negative step size while declaring a single dimensional array. So for example, let's just declare an array P. These names for the arrays are just random. You can call it anything, and it will mostly be based upon the problem that you're working in. So for example, if you are working with concentrations, then you can call your array concentration or anything that specifies the concept that you are discussing during the problem. But here, just for explanation, I'm calling it random alphabets. Right here I declared it as P. And remember that these are case sensitive, so if I write a capital P, or if I write a small p, lowercase, these two would be considered two different variables, so be aware of that. So what was I discussing? Yeah, I was discussing about the negative step size. So let's say an array starts from 200. It is having a negative step size of, let's say, -50, and it terminates at 0. Again, you can enclose it inside square brackets, but these are not necessary for single dimensional array. So 0. So let's run it. Now if I check the values for p, you can see that it starts from 200. Since it's having a negative step size, so 200 minus 50 is 150, then minus 50 is 100, and so on, and it terminates at 0. So and during the declaration of single dimensional arrays, it can also have a negative step size. Alright, so I was discussing earlier about MATLAB indexing into arrays. Indexing is a very important concept in MATLAB, and it is used most of the times with arrays. So you'd be using MATLAB indexing for a lot of the time, and it is very much necessary to discuss it right here and to understand how indexing inside a MATLAB arrays works. So for example, I've declared here a simple single dimensional array, or I haven't. Yeah, I didn't. So let's declare here a single dimensional array, 1D array. Let's call it AA. I don't know. So let's start it from 10 to 20. So remember, when you don't specify the step size and you just specify the two values and put a colon in between them, then by default the step size is considered to be 1. So if I don't specify any step size like I did here, it will by default take a step size of 1. So that's important to note. So when I declare it, let's print the results for it, AA. So 10, 11, 12 up to 20. So it's a single dimensional array that has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. So 1 row and 11 columns. So how do we index into this single dimensional array? So suppose I want to take out the value 12 from this single dimensional array. How will I do that? So I'll do that with the parentheses, MATLAB parentheses. So indexing in MATLAB is performed with parentheses. So let's store this value 12 in another variable. Let's call it AA underscore 3, which specifies the third value for this the third value of this array. So in order to index into this value, what you will do is that you will write the array variable, that is AA, then you will put parentheses, and inside the parentheses you will specify the number of the element or the entry that you want to index into. So remember that the indexing in MATLAB starts from 1. So if you put here 1, it will take out this value. If you put 2, it will take out this value. If you put 3, it will take out this value, and so on. Why am I saying that? Because in other programming languages, the indexing might not start from 1. Like for example, in Python, the indexing starts from 0. So if I want to take out this value, instead of writing here 1, I'll write here 0. So indexing inside Python starts from 0, but inside MATLAB, indexing starts from 1. So that's really important to note. So if I want to take out this value 12, since it's the third value, so I'll write here 3. So notice the syntax. I write the variable name that stores the array, and then I put parentheses, and inside those parentheses I put the index number 3. So what will happen is that the MATLAB will take out the third entry and will store it in the variable AA underscore 3. Let's terminate this with semicolon. If I run it and I see the value for AA underscore 3, I'll see it returns me 12, which is as expected. So same goes for any value. So for example, let's see. For example, I want to print the value 20, which is the last entry. So if I want to print that, or to fetch that value, I'll write the variable AA, and since it's the 11th value in the array, so I'll write here inside the parentheses 11, and as you can see, it prints up the value 20. Another way to print the last value inside an array is the AND keyword. So if I write AA and inside it I write N, what it will do is that it will print the last value in the array AA. So it doesn't matter what's the length of this array. By length I mean how many entries it have. It will always print the last value inside it. So if I press enter, it has printed the value 20 as expected. If I want to print the first value, I'll just simply write AA and 1 in here. It will give me the first value. So that's how indexing works for single dimensional arrays. Now let's discuss indexing into a 2D array or a matrix. So right here I have declared a matrix C. So if let's first print this matrix so that we can see. So if I write here C, as you can see that it's a matrix having 3 rows and 2 columns. Now suppose that I want to index to this particular value 4. So where does it lie? Well, it lies in the second row and in the second column. Remember that. The value 4 lies in the second row and in the second column. How would I fetch this value? Well, the way to do it is something like this. So let's store that value in a variable. Let's call it C, I don't know, anything, C1. Well, that is not a useful name, but anyways. So again, I'll write the variable for the 2D array C, and now instead of passing it a single number as I did here, now we'll pass here 2 values. The first one will stand for the row, and the second one will stand for the column. So since this value lies in the second row and second column, so I'll write 2, which stands for rows, and 2 for column. So now what will happen is that the MATLAB would go to the second row and second column of this array C, and will fetch that value and will store it in the variable C1. Let's run it and let's see what is inside C1. As expected, it contains the value 4. Same goes for other values, so let's do it here. So for example, I write C3 3 1, so it will go to the third row and in the first column and will return me the value 5. Let's verify it. So in the third row and first column, it contains the value 5. That's what it's returned. The MATLAB is returned. You can try different examples here, and I'll encourage you to do this on your own. So the first row, second column, first row, first column, and so on. Now, one important detail here is what happens if you go outside the range of an array. So, for example, in case of the single dimensional array, let's clean the environment. P, it is having values from 1, 2, 3, 4, 5. So it contains 5 values. What happens if I exceed the index of this row, single dimensional array P? So if I write here 6, now since it is outside this range of this 1D array P, the MATLAB will generate error. So if I hit enter, you can see that it states index exceeds matrix dimension. So it's outside the dimension length. It's outside the range of this P. Same goes for the 2D array. So if I write C, since I know that the C is a 2D array having dimensions of 3 by 2, so it's having 3 rows and 2 columns. But if I write 4 here and let's say 1 here, now I want to print the value for the 4th row in the first column. Now I know that there are no 4th rows in the variable 2D array C. So again, it will generate the same error and states that index exceeds the matrix dimension. So if you exceed the dimension length, the MATLAB will generate this error, and this is a pretty common error. You'd be seeing it a lot of the times as you try new programs in MATLAB. So let's see an example that's given on the slides. So we are having two different single dimensional arrays, and then we have generated a third single dimensional array by taking values from the first two arrays. So let's just copy this code and print it into our script, and I'll explain it right here. I know I'm a bit lazy here, but that's okay. So the first variable here is VR1. It starts from 20, goes up to 44 with a step size of 4. Second variable here, VR2, starts from 50, goes up to 71, and is having a step size of 3. Now suppose that of these two variables, I want to construct a third row or a third single dimensional array by taking some values from these first two 1D arrays. So how will I do that? Well, I've discussed earlier how we can index into the values inside an array. What we'll simply do is that we'll declare a third variable that's a single dimensional array. We'll name it, and here it is named as VR1n equals. In a similar way, I'll enclose the values inside square brackets, so you can see that the square bracket starts from here and terminates at here. Let's put a semicolon also. Now, what is inside this third array? Well, it contains values randomly chosen from these first two arrays. So VR1, 2, what it will do? Well, it will go to the VR1 array and take out the second value of it and will store it in here as the first value of this third 1D array. Similarly, VR1, 3 will take out the third element of the third value in this array and will print it here. Same goes for this one and so on. So let's verify this. I hit enter. run. Let's see. So we are 1. That's the values for we are 1. We are 2. Sorry. Let's clear again. We are 1. We are 2. And now let's print we are 1 and I wrote m instead of n. So let's see. So the first entry here is 24. What is 24? It is we are 1 of 2. So the second value in the row, the 1D array, we are 1. So what was the second value in we are 1? It was 24, as you can see here. So that's where it comes from. The second value is we are 1, 3. So if you see here, we are 1, 1, 2, 3. It's 28. And here it's also 28. The last value comes from we are 2, and it is the 7th value in we are 2. So if you go to the we are 2, the 7 value 1, 2, 3, 4, 5, 6, 7, it is 68, and here it is 68. So that's how you can create other variables arrays based on some previous arrays. So you index into them in this way by parentheses and specifying the index number, and it will automatically return that particular value from that particular array. So you can try other making up other 1D arrays. Let's create one of our own. Let's call it mn equals to square brackets. Let's write we are 2, the let's say 1 first value. Again, you can separate two values by specifying here a space, or you can also put a comma here. Now we are 1, let's say third. We are 1 second. I think that's enough. When I hit run button and I print the value for mn, 50, 28, 24. Where it comes from? Again, let's verify. We are 1, we are 2. Also this. So yeah. So we are 2, 1, or the first value in VR2. What's the first value in VR2? It's 50. So that's where 50 comes from. We are 1, 3. Third value in 3, 28. That's where it comes from. And we are 1, 2, 24. That's where this 24 comes from. So that's how you can index into 1D arrays and create off other arrays based on the values from the previous arrays. So let's see some other examples from the slide. Okay, so you can also construct different arrays, both single dimensional and multidimensional, that's 2D and 3D, by specifying other MATLAB functions inside. So for example, here an array is declared by having entries taken from the linear space function. So what has happened here is that there's a command, this function is called linear space. It's being called inside this array. It starts from 1, terminates at 7, and has 7 values. Then there's a semicolon which terminates the first row, and now the values goes to the second row. Now again it starts from 7, terminates at 1 and has 7 values. Then the second row terminates, and then the third row starts from 2, goes to 9 and has 7 values in between. So let's see this in action. Let's declare variable array m equals to, I'm forgetting the value that's written here, so I'll just copy paste it. Okay, let's format it. Well, it's not being copied properly, so let me fill it myself. You can put any values, just putting the values from the slides so that you have it's easy to understand, or in the context is in the reference. So semicolon, semicolon, semicolon. The values was first one starts 177, starts from 1, goes up to 7 and has 7 points in total. Second one starts from 7, terminates at 1, again 7 points in total. Starts from 2, goes up to 9, 7 values in total. So let's run this command. So when I hit the run button, and let's see the values for M1. So the first row is this one. It starts from 1, terminates at 7 and has 7 points in total that are uniformly spaced. So it's 1, 2, 3, 4, 5, 6 and 7. Because it starts from 1, goes up to 7 and has 7 points in total, that's why the difference between each of them is 1. Second one starts from 7. Now observe this semicolon here. This semicolon has terminated this first row, and now these values come into the second row. So it starts from 7, terminates at 1 and has 7 points in total. So 7, 6, 5, 4 and so on. Again, the difference between these two is 1. Now it's in a descending order because it starts from 1, goes up to 7 and goes up to 1. So that's why the difference is -1 if you subtract this from this one. So pay attention to that. Now again terminates the second row, this semicolon, command goes to the third row. This starts from 2, goes up to 9 and has 7 points in total. So you can see it here. Now all of this is enclosed inside these square brackets, so that's why it is a 2D array. Now if I write the size of M1, I can see the total rows and columns, size of M1. So it has 3 rows and 7 columns. Let's do another example. Now you can also have an array by declaring the rows and the different entries by different methods. So what do I mean by that? So let's see. The first row in this 2D arrays is declared in the step size fashion. It starts from 1, terminates at 7. Since there is no step size given, so the default step size is 1. Now the semicolon terminates the first row. Command goes to the second row. It starts from 7 with a step size of -1, goes up to 1. And this third row is constructed in the similar way as the first one. So basically this M2 would also have the same values as M1, because over there it was starting from 1, terminating at 7 and has 7 points. So the difference or the step size over there was 1, and the same thing happens here. It starts from 1, goes up to 7. By default the step size is 1. Now this one starts from 7, terminates at 1 and having 7 points in total, so it was in descending order, the same linear space. And that's what we do here. Starts from 7, terminates at 1 with a step size of -1. and the third row is constructed in the similar way as the third row in the previous M1 array. So I hope this would be copied properly. If not, I'll have to manually write it. I think it is copied properly. So this is the first row. You can put spaces in between them so that it's readable. These spaces would create no difference. It is ignored. But just to have it clearly visualize it, we put random spaces. So the first row, second row, and the third row. Each row is terminated with a semicolon. So if I run it, CM2, what happened here? So it's the first row, 1 to 7, terminates at this, second row terminates at this, and now the third row from 2, 9, 7. Why is it giving me 2 rows? Oh, I forgot the negative sign in here. A step size of -1, that's why the results were not identical. Let's see it now. So M2. Now, as you can see that the result is identical to M1. You can compare these two. So the important point here is to note that you can have different ways for writing the rows, the different rows inside the same 2D array. So as you can see, I have declared it by calling the linear space function in here, all 3 rows, and here I have combined other ways in order to define this 2D array. Let's see other examples. So what has happened here? Well, here there's a single dimensional array. First 5 points are taken by this linear space, and the second 4 points have been defined by this one. Let's just copy it. I can also manually write these in here, but it will take more time, so I'm just copying it. It's not copied properly, so now I have to write it myself. You can try with different values for these commands. These are just for explanations. I'm taking these from your slides just for your convenience, but I'll encourage you to try other such these commands with other values that should be your own, so that you can have some practice with it. Okay, so starts from 10, 10, 5. Oh, so it's a really interesting example. In this linear space command, the starting point is 10, the ending point is also 10, and it has 5 values in between. So what do you think it will print? Well, let's see. Second one is also the same, 25, 25, 4. So 25 starts from 25, terminates at 25, and has 4 points in between. Now notice that here I have separated these two by a comma and not a semicolon as in there. So here the second values from this linear space function won't go to the second row, rather it will be printed to the first row, because I have separated them by a simple comma and not a semicolon. So that's the first thing to note. The second thing is that this linear space starts from 10. It also terminates at 10 and has 5 points. So there's no like the starting and the end point are the same, but I want 5 points that are uniformly spaced. So the MATLAB would print the same value 5 times, and same goes for this 25. Let's see the results. So if I write v3, as you can see, the value 10 is printed 5 times, and then the value 25 is printed 4 times. So if you count them, it's 5 times and it's 4 times. Why is it repeating the same value? Because the starting and the ending point is the same, and I want this many points that are uniformly spaced. So that's why the same value is printed multiple times. And see that this is a single dimensional vector. I'm saying vector array. An array can also be called a vector, but we won't go into that discussion right now. So, and since it's separated by a comma, so that's why it's in the same row. Let's see another example. So, question 26. Test 1 equals linear space 6, 6, 5, semicolon, linear space 8, 8, 5. Test 2 linear space 6, 6, 5, semicolon, space 8, 8, 5. And then you can see an apostrophe here. This stands for complement, which will interchange the rows and columns. So let's see this in action. The first one is a sample one. Let's try that first. Test 1. So again, it's not properly copied. Six, 6, 5, 8, 8, 5. So starts from 6, terminates at 6, have 5 points. So it will basically print the same value 6, 5 times. Again, start from 8, terminates at 8, 5 values. Again, 8 will be printed 5 times. Now see that there's a semicolon here, so these values will be printed in the second row. So if I run it, write test 1, you can see 666, 888. Second test 2 is the same as test 1, but with an apostrophe on top of it. So it will basically interchange the rows and columns. So test 2 and an apostrophe on top of it. So if I run it and print the result for test 2, you can see that the rows have been converted into columns. So test 1 was something like this, and test 2 is something like this. So this row is converted to the first column, and the second row is converted to the second column. So that's what an apostrophe do. It takes the complement of it. What does a complement mean? Complement means interchanging the rows and the columns. Let's see some more examples. So here, these are also almost the similar examples that we saw earlier, but let's try them. I have to manually write them. So let me write them and then I'll be back. So in this example, first let's note the name for this array. So as in the previous lecture, I discussed that an array can have any name based on some rules. One of the rules was that it cannot start with a integer or any numeric value. So here I have named it as the question number 27 part A. You can also put underscores if you want to separate two names from each other, but so you can have also have names for the arrays, something like this. So inside this array, what is happening is that again starts from 1, goes up to 1, have 4 points. This linear function returns 4 values, and all of them are the same because it starts from the same value, terminates at the same value, which is 1. Then a semicolon terminates the first row. Here's the second row, terminates the third row, which also has the same values, and it terminates the final row. Starts from 8, goes up to 2, and have 4 points. So let's see what the result looks like. Oh, I have an error. Dimension of matrices being concatenated or not consistent. Line 51. Okay, so the error arises in this. Let's leave it for now. We'll see what the error is. But let's see the result for this array. So if I write Q27A, you can see the result here. So the first row, 4 values, 1, 1, 1. Second row the same, third row the same, and the final row you can see it starts from 8, terminates at 2, and has 4 points in between. So that's what this 2D array looks like. Okay, so the error in this second question 27b array is that since here the first row contains the values 1, 4 ones, as like in the question 27a, second row is also 4 ones, third row is also 4 ones, but in this final row, what is happening? If you see the result for this command, the value starts from 1, takes a step size of -2, and goes up to 4. If you see the values that it is generating is 3 and not 4, so it's starting from 8, step size of -2, and when it reaches 4, the total values are 3. But on the earlier 3 rows the values were 4, so this final row is not being matched in size with the first 3. That's why it's generating this error. So if you run this, it is telling us that the dimensions of matrix being concatenated are not consistent. It means that the first 3 rows are of 4 values, so they are having 4 values, but the final row is having only 3 values, and you cannot concatenate. Concatenation means that you cannot put together 3 rows that are of size 4 and the final that are of size 3, because it will then have an empty space in the last, and MATLAB does not allow you to do that. So that's why it is generating this error, and that's what this error means. So we would comment this line so that MATLAB ignores it. Okay, this one, question 29a. So what's happening here? It is generating the first row starts from 0, goes up to 0, and have 6 points. So basically it will have 6 zeros. The second one the same. Third one is starting from 0 going up to 0 and having only 2 values. So again, notice that these two arrays are not being consistent in size to this third one. Like they are having 6 points and this one is having only 2 points. So again, okay, but also notice this. Okay, so it's interesting. This last two commands are not being separated by a semicolon, so these two will be printed onto the same row. So first 2 zeros come from this one, and the last 4 values comes from this 2. So 2 plus 4 is 6, and the first 2 rows are also of size 6. So that's why this one won't be generating any errors. At first I thought that this is being separated by semicolon and it is having only 2 values, it will generate error, but as you can see it's not being separated by semicolon, so these two will print the values onto the same row. 2 values will come from this and 4 values come from this. In total they will make 6 values, and it is being consistent with the first 2 rows, so that's why it won't generate error. Let's see the results for it. Question 29a. So as you can see, the first row all zeros, 6 zeros, the second row 6 zeros that are coming from these two commands. The last two, as you can see, the first two zeros come from this command, these two, and the last four values comes from this one. So it starts from 8, goes up to 2 and have 4 points in between. So 8, 2 and total 4 points. So that's how this one, this 2D array is generated. Alright, so in this question 29b, it's just a name for this array, 2D array. Before discussing it, I'd like to discuss another interesting MATLAB function called the zeros. So what does the zeros function do is that it generates zeros of a particular size that you are specifying it to. So for example, if I write zeros of size 1, it will generate a single zero. I know it seems like a useless thing, but believe me, it's really a useful command, and you'd be using it a lot as you proceed through this course. So if I write zeros of, let's say, 1 and 3, so what does it do? The first argument specifies the number of rows, and the second one specifies the number of columns, and all of these entries would be zeros. So if I hit enter, it's having 1 row, 3 columns, and all of the entries are 0. I can write 2, 3, it will now have 2 rows, 3 columns, all zeros. I can write 3, 3, 3 rows, 3 columns, all zeros. You can put any number in here and it will generate you all the zeros. If you write zeros of just 3, it will create a 3 by 3 2D array that's having entries all as zeros. If you write here 5, it will now be 5 by 5. But if the rows, the number of rows and the number of columns are different, then you have to specify it. Like for example, if you write zeros of 5 to 5 and 6, it will have 5 rows, 6 columns, and all zeros. So that's what the zeros function does for you. Okay, so in this array, the first row comes from this zeros function, so it will have 2 rows, 6 columns. Now this is interesting. Inside this array, here comes another 2D array that's having 2 rows and 6 columns. Then the column is terminated. Sorry, not the column is terminated, the row is terminated. The second entries come from this function, linear space, starts at 0, terminates at 0, having 2 points. Then the row is not terminated, rather it's separated by a comma, so this will also come to the same row where it starts from 8, terminates at 2, and have 4 points. Let's see what it generates. If I write question 229b, alright, so it's giving me this array. Let's understand this. So the first 2 rows and 6 columns comes from this command. So the first 6 columns, the first 2 rows, which are these 2, and 6 columns, so 1, 2, 3, 4, 5, 6. Okay, so this matrix or this portion comes from this command, zeros of 2 to 6, 2 and 6. Now this row is terminated, so this row is now terminated, and these two come to the next row, which is this one. And in here, the first 2 zeros comes from this command. These are these 2, and the last 4 entries come from this command. Because it's separated by a comma and not a semicolon, so it's not going to another row, rather it's printing these values on the same row, and it comes from this command. Well, I know that it seems a bit confusing just by looking at it, but I'll encourage you to try this on your own and try some different commands and different numbers for these commands, and see what kind of matrices or what kind of 2D arrays and single dimensional arrays you can generate with it, play with it, and have fun.